Okay, so yesterday we ended here with, I don't think we ended here. I think we ended a little later. We did end there. Okay, so we talked about positive and negative angles, right? Positive, you rise, correct? Counterclockwise. Negative, you fall. And alpha, beta, and theta are just names of angles. And coterminal, they share what side? The terminal side. So we have alpha and beta, an example here. We have beta and alpha, and we have an example here. And we'll talk about coterminal angles in a few seconds again. So radian measure. So when I introduced radian measure to you yesterday, I talked about radian reminded us of radius, correct?
Yeah.
So what a radian is, 1 radian, and I touched it, 1 radian is equal to the length of the radius on the circumference of the circle. So it's like I took a piece of string and measured from the center to out to the circumference and have that length, and take that piece of string and lay it on the circumference of the circle. Right there. Make sense? Now, would you believe me if I told you every single circle, no matter the size, has approximately the same number of radian in it?
Yes, I would.
Would you?
Yes, Professor Beck.
So, that circle, that circle, that circle.
Just make I believe when people say there's gold written on the ceiling.
Okay. There is approximately 6.28 radian.
Because it's 360 degrees, so they all should have the same.
Yes, they all should have the same. Radian and degrees are the same. They're measuring angles. They have a conversion factor, which we will learn in a second. But there is approximately 6.28. Where do you think I get that number from?
Looks like a certain type of baked food.
Pi squared.
Not pi squared.
Pi times 2.
Pi times 2. There's approximately, because from here to here is actually pi. And so all the way around is 2 pi.
Yeah.
And we'll keep talking about that. But there are approximately 6.28 radian in every circle, no matter the size. This little pin circle right there. I need a big circle, but I don't have a big circle in here right now.
That lampshade.
The lampshade. Every circle you see has approximately the same, because you are taking that circle's radius and laying it, and it will cut it.
It's not like 6.
No, it's not, because there's 3.14 in 1, right? So I didn't cut it up right.
There's 6.28 what?
I don't know, whatever the next digits of pi are. So,
It's looking like
okay. But anyway, I'm not going to ask you to divide it. So again, a radian is the measure of the radius on the what?
The circumference.
The circumference of the circle. You just need to understand that, what it is. There's 360 degrees in a circle. There is 2 pi radian in a circle. So, obviously, is there a big difference when writing the numbers? Like, if I said something is 36 degrees, is 36 degrees going to be equivalent to 36 radian?
Mm-hmm.
Probably not, right? Okay, because a radian is much bigger than a degree. And I'll show you that conversion factor here. Oh, not quite yet, evidently. The definition of a radian is, don't write this down yet because I don't want you to. 1 radian is the measure of the central angle that intercepts the arc. So I have a circle and I touched it. Again, do not write this down. I have a circle. We always draw this nice coordinate plane, and we have an angle. This is called the central angle because the angle is made, guess what? With the
Center.
The center. Okay? So what that is theta equals S, which is arc length, and R. So if I want theta, I have S over R. And theta will be in radians when I do that, and we're going to have another slide where this comes up on. But that's just showing you what it is when we're talking about 1, when the unit of measure is 1. Again, I already told you there's approximately 6.28 radians. That picture is much better than mine. If you had to guess the degrees here, what do you would think? This is what? Here is 90, isn't it? In the center
50.
would be 45.
60.
Okay. 55, 60, somewhere like that. And we'll calculate exactly what that is here in a second. But again, is radian larger than a degree?
Mm-hmm.
Yes.
Much larger.
Much larger than a degree. Okay, because the measure of an angle of a full revolution is S. This is just a breakdown. You don't really have to write it down. You just have to understand it. S equals R, yes, because I had theta equaled S over R. Correct? S was the arc length. If we're talking about a full circle, what is 2 pi R? What is that equation of?
Area.
Not area.
Circumference.
Circumference. This is the circumference of a circle. Yes? Divided by the radius. And guess what I get?
The answer.
I get 2 pi radian, which I already showed you in your picture. If this is 2 pi, then half of it is only what? Pi. And you probably already can get the conversion. What's from here to here is how many degrees? 180. Well, how far is just to here?
90.
90. Well, how much of pi is that?
A quarter.
Half.
Oh, pi. Oh,
Yes?
yeah.
And if I go all the way down here, that'd be 180 plus another 90,
270.
270. And if this is a half a pi, 2 halves, 3 pi over 2. And then I have 4 pi over 2, which is what? 2 pi. So there will be angles that we're not going to use the conversion on. We're just going to know. And we're going to work towards that. And I have these down here. A half a revolution is pi. A fourth is pi over 2. If I wanted a sixth, yes. If I wanted a sixth, I'd have pi over 6. Okay, how many times does 6 go into 180? 30.
Yeah.
Okay, so this is the same. Actually, I'm sorry. Scratch that. How many times does 3 go into 180? 60. So pi over 6, guess what? Is 60 degrees. So if I ask you pi over 4,
40.
how many times does 4 go into 180?
I don't know.
45.
45. So it's what? 45 degrees.
What is next? What is next to the 180 and the 270? Up on your circle.
Oh, this is 180 and pi. 3 pi over 2 and 270. Okay, how many times does 6 go into 180?
30.
30. So it's, guess what?
30.
30 degrees. Those are ones we're going to know. You're going to see pi over 6 and know it's 30 degrees. If nothing else, you're going to say 6 goes into 180 how many times? 30. And you're now 30 degrees. These are ones we are not going to use the conversion factor and do the whole formula after pretty much today. Now, there will be angles like 86 degrees, that I will be using the conversion factor every single time I see it. But I'm not going to do it on 30, 45, 60. Are those all even divisions of 180 and 360? Yes. Okay.
Can you work out the 86?
Yep, we will in a second. Okay, so I was ahead of myself. What?
I was still writing.
What were you still writing? Were you still writing this? Like what I have here, basically? The pi over 6, that?
I was on the last one.
Okay, so it's pi over 6 with 30 degrees. Okay, so this is just a picture. Their pictures are probably a little bit neater than mine, but I like mine better. Again, 6 went into 180 how many times? 30. So what is this degree?
30 degrees.
30 degrees. Pi over 4. See how it's a fourth of it? It is 45. Pi over 3 cuts it in thirds. So 180 divided by 3 is what? 60. Fractions are our friends, guys. It's going to be a lot about fractions. Okay, half of 180 is 90, 180, and 360. Okay?
Why was there 270?
I don't know. They only did the first quadrant angles right now. We will actually do these angles like this is 60 degrees here and it's 120 here. Yes? Because 60 plus 60 is 120. And if you have pi over 3 plus pi over 3, you have what? 2 pi over 3? Okay, so any angle, you will know that this is 4 pi over 3. And you will know we were actually supposed to do it tomorrow, but it won't be tomorrow now. And this one is going to be 5 pi over 3. Okay. We will know those angles. We will know the 60 degree in all 4 quadrants. We will know the 30 degrees in all 4 quadrants. We will know 45 in all 4 quadrants. And it just comes down to fractions. And it will be, once you get how to get them, it will be very simple. Okay. Are we good? I didn't ask it last time and got myself in trouble. Are we good?
Mm-hmm.
Okay. So quadrants, we want to talk about it. We talked about it yesterday. We have quadrant what? 1, 2, 3, 4. Quadrant 1 is from 0 to 90, which 90 is what? Pi over 2. The reason why we do radians is you do not graph the sine. Okay, the sine wave looks like this if I graph it. Let me graph it for you. If I don't graph it in a circle, the sine wave looks like this. If I graph it in a circle, the sine wave looks like what?
A circle?
A circle. Okay?
Crazy.
So when we take it out of the circle, we always graph in radians. And so that's why it's very important to know the difference and be able to use them. When you hear pi over 2, you should think what? What degrees? 90. When I hear pi, I should think what? 180. When I hear 3 pi over 2, not quite yet, but you'll get 270.
270.
Okay, that's going to take a minute because that's not one we normally use a lot. But again, they say from 0 to pi over 2, which is 90. From pi over 2 to pi is the second quadrant. From pi to 3 pi over 2, or 180 to 270 is the third. So when I say the angle 315, what quadrant am I in? The fourth, right? Because we have 270, so and this is 360. Yes, 360. So you know it's somewhere there, right? When I say 137, what quadrant am I in? Two. Okay. You'll need to know what quadrant you're in because you need to know whether things are positive or negative. Okay. In the first quadrant, what's positive, X or Y, or both? Both. In the first quadrant, we have positive and positive for the X and the Y, correct? Okay. You're going to learn that cosine is X and sine is positive. I mean, sine is Y. Sorry, I said the wrong one. In the second quadrant, what's my X, what's my Y? Negative, positive. So cosine will be negative and sine will be positive. The fourth quadrant, they're both what?
Negative.
They're both negative. So both sine and cosine are negative, so that means tangent's positive when you start learning those. And in the fourth quadrant, X is
Positive, negative.
and negative. Okay? Those are things we already know if we stop and think about them, and we're going to be able to use them in different ways. These very first sections are very, very, very important in the understanding of the later ones. So please do this homework when you're assigned it. Tell me when I'm good.
You're great, Mr.
Brad still.
I'm still on too. Yeah.
I was going to say, there are several people writing.
I couldn't see Natalie. Sorry. She's like covered right
But
next to
am I out of tissues? I'm out of tissues over here too. I got paper towels, or you can go get some.
Are you done writing, Brad?
Yeah.
I was like, if you're not, I can go get them.
Yeah.
Nick,
What?
I text my mother about when Dad has to go get his staples removed in his hip real quick.
Today?
Yeah.
No, today. That's when he's getting in bed.
What are you doing?
But what? I need to know what time.
Real quick. Now, let me know when you're done. Good? Okay. So, coterminal. Remember, coterminals share what? Terminal. Now, technically, they share both the initial and the terminal, but we just need to know they stop at the same place. Okay? So, the picture of a coterminal angle was, I keep having my eraser on. Here's my circle, right? So, if I came here, this angle, when I came this way, and when I came this way, yes? Now, the positive angle is something less than 180, correct?
Yep.
The negative angle would be greater, the absolute value of it would be greater than 180, wouldn't it? Be like negative 190 something. Okay, when I add those two things together, what do I get? When I add the positive and the negative, what do I get? 360. So, 0 and 2 pi, they are coterminal. Aren't they the same thing? If I leave 0 and come all the way around, I get 2 pi. Okay? Pi over 6. And don't write your fractions like this. You need to be writing them pi over 6 and 13 pi over 6. It was the way this was formatted, and I would exchange it. No, the reason why you need to do that is we will be doing all the math with these fractions. And isn't it much easier to do fractions with fraction math when here's the top and here's the bottom? And it will just keep your brain straight. So the big thing here is to find a coterminal angle. Guess what we add or subtract? 2 pi or 360. When would I add 2 pi? When it's in what major? What kind of measure is it? Degree or radians? 2 pi is radians. So when it's in radians, we're going to add what? 2 pi. When it's degrees, we're going to add what? 360. We can add or subtract either one. So if I want a coterminal angle to 75, okay? If I want coterminal to 75, I can add 360. So I get 435. 435 is greater than 1 revolution, correct?
Yes.
But is it still coterminal? Yes, it's still going to stop at the same place. But I could also subtract. And I can put the negative just like this, can't I? Yeah. So that would be 5, and that would be 15, that'd be 8, so that'd be 2. So it'd be negative what? 285. Those are both coterminal angles to 75 degrees.
Do you have to do both subtraction and addition?
I will, like on the test, I will say give me a positive and a negative coterminal angle. Okay.
Of that.
Yes. So what if I started with like 572 degrees? If I subtract 360 once, do I still have a positive angle? Yeah. So if I was asking for a positive and negative, just because I subtract, I don't have a negative angle, do I? I got to do it again, don't I?
Yeah.
So negative 360 again. So I put it backwards. So that's going to be what? 8, 5, 4, 1. So negative 148. So 572, 212, and negative 148 are all coterminal. Could I subtract 360 again?
Yes.
Yes.
Because
Could I?
angle theta has infinitely many coterminal angles.
Yes, because it says it right there. I could add 360 to 572. There are infinitely many coterminal angles. So what we do is we take the original angle theta and put plus or minus 2 pi n if it is in radians, correct? If it is in degrees, it would be 75 plus or minus what? Not 2 pi, but
Just a second.
what's 1 revolution?
360.
360. Now, I'm going to tell you I'm probably the only person in the world that puts plus or minus. Most people just put plus. N is the number of revolutions, whether it's positive or negative. Now, when I count, do I count negatives?
No.
No, I say like counterclockwise, correct? So that's why I put plus or minus there, because I really have a hard time saying the number of things is negative. That makes no sense. In the book, if you look, it will just say plus 2 pi n, or it will say plus 360 n. If you don't put plus or minus, I'm not going to say anything, but I will always write plus or minus, because logically it makes no sense not to. So I have pi over 6, and what was that in degrees again? 6 goes in. 6 goes into 180. How many times? 30. So it's 30 degrees. So if I had pi over 6, I would add or subtract 2 pi. If I wanted infinitely many, all I have to do is throw in a n. And I write it 2 pi n, guys. I don't ever put the n in the middle. That's weird to me, because 2 pi is a number, isn't it?
Yep.
Like n is the variable. Variables go at the end. So it's weird to say 2n pi, but that's how the book writes it. So I wanted to show you. So fraction math, yes. Pi over 6 plus 2 pi, I have to have what? What do I have to add that?
Common denominator.
Common denominator, which is going to be 6, which makes the 2a what? 12. So it would be 13.
13 pi over 6.
Yes?
Yes.
Okay, don't forget your fraction math. Okay, we've done this, but that's okay. 1 positive, 1 negative coterminal to 13 pi over 6. Well, I just told you that one, so we know. So we have to do what? Add and subtract?
Yep.
So I have 13 pi over 6 plus, and 13 pi over 6 minus. And what are we plussing and minusing?
Pi.
Not pi.
Yeah, 1 term co-
2 pi.
Pi.
2 pi. But I have to have common denominators, so it's going to be what?
12.
So we're doing 12 pi over 6 and 12 pi over 6. So if I add, I get what?
25
25 pi
over 6.
over 6.
Yep.
Subtract, I get.
Pi over 6.
Now, could I have added 4 pi?
Yeah.
Because that's how many revolutions?
2.
2. Could I add 8 pi? Could I add 7 pi?
No.
No.
That would have
It'd be half of, it'd be like, what, 3.5?
It would be 3.
It has to be a whole revolution. Does everyone understand what I'm saying here? Because the biggest mistake I get with here is people go, ooh, I'm going to add 90 degrees. What? Think about it. You have to get all the way back around the circle, don't you? So that would be a whole revolution. Okay, 1 positive, 1 negative to negative 2 pi over 3. So I got to add and subtract what?
I'd say about 12 pi over 6.
Nope.
2 pi again.
Over 3. Something.
Over 3, so it's going to be 6 pi.
Yeah.
Over 3.
So 6 pi over 3.
Is Ron supposed to be negative or minus?
There, right here.
But they're.
Oh, I get what you said. This one. I'm like, it is a minus.
They're the same.
Sorry. Well, it could be if it was over 1 revolution, right? But in this case, it's not. Okay, so I get what?
4 pi over 3 and negative 8 pi over 3.
Yeah. So if I started with like negative, oh my gosh, 17 pi over 3, would I have to add for a while to get a positive?
Probably.
Well, when I'm only adding 6. So in that case, I could have added twice, right? But just make sure you keep going until you have a positive and a negative. And does the same thing apply with degrees? Yes? Okay. But it's not 2 pi, it's what? It's not 2 pi, it's
What?
360.
360. Thank you. Okay. Complementary, supplementary, review from geometry. Complementary angles add up to what?
90.
90. Supplementary add up to
180.
180. Do you need to remember that?
Probably.
No.
Probably.
Pictures help.
Like I said, there is a lot of information in this. We've got to get to conversions, and I'm sure it's the next one.
Oh, what if it's not?
You better check.
Am I good?
Yeah.
You got this off, so leave.
Oh.
Alright, you got yours?
Brad, you good? Okay, again, complementary is 90 in degrees, right? 90 degrees. How many radians?
One hot. Yes.
Okay.
Pi over 2. Yes?
Yeah.
Because 90 is half of 180.
Yeah.
Supplementary is 180, but what in radians? Pi. Your brain is going to get where I say pi, it's 180. I say 180, you can go pi. They are the same thing. Am I good?
Yeah. 180 for pi.
Okay,
It's not the next slide, but it is it.
This is degree.
okay. So don't worry about the top. Those are things I've already said. Okay, so 360. Okay, 360 is 2 pi radian. Yes?
Yeah.
Okay, I'm going to tell you right now, you've never seen rad after 2 pi, have you?
No.
I've just put 2 pi. If there is no degree, it is radians. Does that make sense what I'm saying? So if you want 5 degrees and you just write 5, you've told me what? 5 radians. And 5 radians is almost a complete revolution, correct? 5 degrees isn't even out of the first quadrant. So don't forget your degree symbol. Got it? You do not need to put rad behind radians. So if I have 360 degrees equals 2 pi, then I divide by 2, I get 180 equals pi, correct? So that was quick. Okay, my conversion factor, guys, is what? Pi over 180. So do everything but converting between radians and degrees. Got it? There'll be lots of coterminals. There you go, Elena. Oh.
Whoa.
No, you're fine.
Okay. Do everything but converting unless you want to just look in the book.
Okay.
Okay? So just worry about the 7 through 46.